Hello dear students, today we are going to discuss about electrochemistry. So this chapter I teach in multiple videos and cover all the concepts including questions. Just before starting this chapter, we are going to brief redox reaction basics like oxidation, reduction, all other things. After that we cover galvanic cell and function of galvanic cell, E0 cell, all other things, SRP values, everything. And finally we also discuss SHE and how to measure standard electrode potential values for other elements with the help of SHE. In the coming videos I am going to cover Nernst equation and electrolysis, qualitative, quantitative, Faraday laws and other things. And you starting the lecture, first basics of redox reactions. So in that, the first one, oxidation process. These definitions most of the students know. Just like briefing, oxidation means several definitions for this: gain of oxygens or electronegative elements, or loss of electrons, or increasing oxidation number. Increasing oxidation number, these are the definitions. So simple example, Zn if it converted into Zn2 plus with 2 electrons. So your loss of electrons or increasing oxidation number, that is 0, 2 plus 2. So similarly, reduction. So reduction is nothing but just opposite to this, gain of oxygens, gain of hydrogens or electropositive elements or decreasing oxidation number. Decreasing oxidation number. We can also add for the oxidation that loss of hydrogens are electropositive elements. Same way we can write here that loss of oxygens are electronegative elements. So these are the basic definitions for oxidation. In any electrochemical or electrolytic cell, at anode always oxidation takes place. Always oxidation takes place means loss of electrons. The sign may be different for anode and cathode, depends on the type of cell, but process always oxidation at anode. And similarly at cathode always reduction takes place, means gain of electrons. Reduction takes place. So here one more thing, oxidizing agent and reducing agent. Oxidizing agent means the substance or the agent which undergo reduction. Same way, reducing agent means which undergo oxidation. Reducing agent which undergo oxidation means loss of electrons. That is why generally metals lose electrons and behaves as reducing agent. Non-metals generally gain electrons, behaves as oxidizing agents. So these are the basic definitions which we are supposed to know. Now we are directly started what is electrochemical cell or galvanic cell. So here you are supposed to understand what exactly electrolytic cell and electrochemical cell before going to electrochemical cell completely. Electrochemical cell. So electrolytic cell means we are converting electrical energy to chemical energy with a device. It's called as electrochemical cell. So what is electrolytic cell? What is electrolytic cell? The device which is used to convert electrical energy to chemical energy. Similarly, electrochemical cell means the device which is used to convert chemical energy to electrical energy. So the device which is used to convert chemical energy to electrical energy, or simple way, with the help of chemicals we generate electricity in case of electrochemical cell. In case of electrolytic cell, with the help of electricity we make chemical reactions. So that's how the electrolytic and electrochemical cell will happen. And how to define electrochemistry? So in this chapter we are going to discuss interconversions between chemical energy to electrical energy or electrical energy to chemical energy. That's how we can define electrochemistry. So we can also add few more points for this. So this is non-spontaneous process. Why it is non-spontaneous, students? Because we are taking external current and make the chemical reaction. That's why it is non-spontaneous. So wherever non-spontaneous reaction is there, their delta G value is greater than 0 and E value will be negative. E cell value. What is E cell? We'll discuss. Just a few points. Here, spontaneous process, since without external energy we are making this process. Spontaneous process. So delta G value is less than 0 and E cell value will be positive. So these are the basics which you are supposed to understand. First we are going to discuss completely about electrochemical cell. Then we are going to discuss electrolytic cell. So we are going to start that. Just in this what I told, the basic terminology which are frequently used in electrochemistry like oxidation, reduction, cathode, anode, oxidizing and reducing agent. Then we discussed types of cells in electrochemistry. In electrochemistry we mainly focus on the interconversions between the electrical energy to chemical energy and chemical energy to electrical energy. This is galvanic cell, students. So in this there will be two half chambers. This is anodic half chamber. This is cathodic half chamber. So in this 1 m concentration of ZnSO4 along with Zn electrode which act as anode, and the other half cell contain CuSO4 same 1 m concentrated and Cu electrode which is dipped in CuSO4 solution, and both are connecting through external circuit and voltmeter. So we already know that Zn is more reactive than copper in the reactivity series of metals, or Zn is having low SRP value and behaves as reducing agent. What is SRP? We will discuss once this is done. This is high SRP value. So low SRP value or high reactive metal behaves as anode. High SRP value one behaves as cathode. Now, so at anode which reaction takes place? Always oxidation takes place. So Zn electrode converted into Zn2 plus 2 electrons, and this is Zn electrode whichever is here, that give Zn2 plus ions into the solution and 2 electrons present over the electrode. That's why anode sign in case of galvanic cell is negative charge, and those electrons started moving from anode to cathode. So at cathode what happens we can discuss. So we are taking CuSO4 as electrolyte in case of cathodic chamber. So that split into Cu2 plus and SO4 minus 2. So these Cu2 plus ions from the electrolyte take the electrons which are coming from anode and happens reduction. So cathodic reaction is what, students? So Cu2 plus ions from the electrolyte take up 2 electrons which are coming from anode and become Cu. So this is gain of electrons, so it is reduction process. So until here very simple. So anode giving electrons, cathode is taking up electrons, and during this you supposed to know one thing. Over some time Zn2 plus ions increased in the ZnSO4 solution because the electrode is giving Zn2 plus ions into the electrolytic solution. That's why over a period of time Zn2 plus increase than SO4 minus 2 ions at anodic chamber. Similarly, at cathodic chamber SO4 minus 2 ions increase than Cu2 plus ions. That's how at anodic chamber positively charged ions increases, at cathodic chamber negatively charged ions increases. So this positive negative charge imbalances in two half cells. That is how the potential difference exists between these two half cells. That potential difference calculated with the help of voltmeter. So that will help, this voltmeter help us to find E0 cell of the reaction, E0 cell or EMF of the cell. Here wherever not comes, that indicate for standard conditions. Standard conditions are this one. Temperature supposed to be 25 degrees Celsius. Concentration is 1 m like 1 m H2SO4 and 1 bar pressure. So 25 degrees temperature and this is concentration and 1 bar is the pressure. So those are the standard conditions. As we discussed, so at anode Zn2 plus ions increased, at cathode SO4 minus ions increased. So here positive charge increased, here negative charge increased. Due to that potential difference will exist. That potential difference, if it is too much, the redox reaction will disturb. To avoid that excess charges, we are using a U-shaped tube called as salt bridge. The salt bridge generally contain NH4, NO3 or KNO3 electrolyte along with a solvent called as agar-agar. Just it is a solvent, it mix up uniformly those positive and negative ions of the electrolyte. So what is the work of the salt bridge? We just discussed. We are taking KNO3 in the salt bridge. It split into K plus and NO3 minus. So K plus ions move towards cathodic chamber and neutralize the excess SO4 2 minus ions. Same way NO3 minus moves towards anodic chamber and neutralize excess positive ions. That's how the salt bridge will help us to prevent liquid-liquid junction potential and maintain electrical neutrality. So these are the major uses for salt bridge, and there are exceptional points for this. KCl is not used. KCl not used as electrolyte in case of silver, thallium, lead and Hz. And here why we have to take specific electrolytes in salt bridge? The reason is the current carrying capacity and mobility of anion and cation should be same. Mobility of ions should be same. And also salt bridge ions supposed to be inert, means it should not react with the electrodic ions or electrolytic solution. So these are the some specifications about the electrolytes which we are using in the salt bridge. And what are the main applications of salt bridge? This is very important. Applications of salt bridge. What purpose we use? Just we will discuss that. It is used to maintain electrical neutrality. Coming to next. So it is used to complete inner circuit. Without mixing of two solutions of anode and cathode. And also it maintains liquid-liquid junction potential. Now we need to understand representation of cell and calculation of E0 cell. So representation, however, we have given in the diagram same way. Left side anode, right side cathode. Here in between two lines we indicate for salt bridge. So we know that at anode what reaction takes place? Zn converted into Zn2+. The concentration we need to represent here along with aqueous medium. And similarly in case of cathode, Cu2+ converted into Cu. So here also concentration and physical state we have to write it, which is aqueous state. That is how we represent cell. Coming to E0 cell. E0 cell can represent with the help of SRP values. So that is E0 cathode minus E0 anode. There are many ways to write it the same. E0 cathode minus E0 anode. So in this we can also represent E0 reduction minus E0 oxidation. And we can also write E0 positive minus E0 negative. So what exactly E0 in this? Just we take SRP values. So SRP value means standard reduction potential. So the tendency, how effectively the tendency of reduction, simple. So how effectively the reduction happens for any element is called as SRP values. So SRP values, generally if it is low SRP value considered as strong reducing agent, and also low SRP value strong reducing agent and easily undergo oxidation. Oxidation is easy. Means high SRP value is nothing but behaves as good oxidizing agent and also undergo reduction easily. So generally non-metals have high SRP value, metals have low SRP value. In that hydrogen having 0 SRP value. So this is what SRP, the same SRP value need to use for the above cell. If you take E naught cell equals to E naught cathode minus E naught anode. So here we are taking reduction values, so that while representing in this, you are supposed to indicate both in the reduction form. At cathode, reduction equation is Cu2 plus 2 Cu. At anode, we need to indicate same reduction values, Zn2 plus 2 Zn. So these values they will give in the question. So Zn2 plus 2 Zn value will be minus 0.76. I already told, right? So lower the SRP, better the reducing agent. Means it easily undergo oxidation. And Cu2 plus 2 Cu value is just minus, sorry, not minus, 0.34 plus 0.34. If you substitute here, so 0.34 minus of minus 0.76, which is equals to 1.1 volts. So this is E naught cell value. So I already told you E naught cell value, if it is positive, the process is spontaneous. That is why it is electrochemical cell. When E naught cell is positive, delta G value will be negative. That's how we can understand this point. Here few conditions you need to understand. If E naught cell value is less than 1.1, then the cell will work properly as like this. So redox reaction happens very smoothly. Cell work normally or properly. Suppose E naught cell value more than 1.1, then this cell become reversed. That means it become electrolytic cell. It become electrolytic cell, because the current will pass and it become electrolytic cell or non-spontaneous. And if it is 0, E naught cell value equals to exactly 1.1 volts, then the cell will work, then the cell stop working. So these are the conditions, representations and other related stuff for the Daniel or galvanic cell. Why can't we use ammeter in the place of voltmeter? Very simple. Or what is the work of voltmeter in this galvanic cell? See here, galvanic cell creates potential difference between two half cells or two electrodes. We need an instrument to measure that potential difference, so that we use voltmeter. So voltmeter main purpose in case of galvanic cell. Or Daniel cell also same way. What exactly does it measure? It measures EMF of the cell, electromotive force of the cell, under open circuit conditions. Here no current is flowing. Very important. Few important points during this process. See, electrons moving or traveling from which place to which place? Anode to cathode. Very important. Anode to cathode. When electrons are in this direction, current is in opposite direction. So current is in opposite direction. This gives true cell potential. Here current is in opposite direction. That means current is moving through voltmeter. Is that correct? No. What is that? I'll tell you. So what exactly EMF is just how strong the cell is and whether the reaction is spontaneous or not. Just those are explained with this, because there is a formula and other things I'll tell you now. See, why voltmeter is used? Because voltmeter is having more resistance than ammeter. So the current will be negligible which passing through the voltmeter. So that we use voltmeter to find the potential difference in case of galvanic cell. That's all. And why not we use ammeter in this case? Same reason. Ammeter measures current, not potential. Ammeter have low resistance. It allows current to flow and changes the cell condition or cell reactions. Voltmeter has highest resistance, negligible current. So the reactions which happens at anode and cathode won't get disturbed. These are the related points about why we use voltmeter or other things. Standard reduction potential. So standard reduction potential means how effectively the element undergo reduction, in simple way to understand. So these values all are given based on reduction tendency, not based on oxidation tendency, even it is for metal. So if you take M1 plus N electrons and convert it into Mn minus, this is the basic, or M1 N minus. This is just a reduction process. So M1 taking 2 electrons, N number of electrons, and converted into M1 N minus, like this. Second metal is m to n electrons and converted into m to n minus. So both reduction values only. If the first metal is more reactive, or you just take this value is SRP value is minus 0.76, this value is minus not minus 0.34. So what I am telling is these all values based on the reduction tendency. First element is having minus 0.76, second element is having plus 0.34. Then how to decide nature of these things? You can write very simple manner. Lower SRP elements behaves as elements are good reducing agents. Lower the SRP, more the reducing power. That's the meaning of this. Reducing nature and undergo rust easily or oxidation easily. Means higher the metal higher the reactivity of metal, higher the reducing behavior, and for them lower the SRP values. Same way, higher the SRP value, higher the SRP, better the oxidizing nature. Better the oxidizing nature. So here
this SHE and applications of SHE and working principle in the second lecture video. So don't miss, surely it will help.